Okay, so hey guys, I'm going to go over day 3 notes, molecular geometry. So basically for molecular geometry, the only thing you guys need to know is this chart right here. Okay, and the good thing about this chart is that it will be provided for you for your test and your quiz, so you don't have to memorize it. Okay, I also want to tell you guys that you do need to know what the Vesper Theory is. It's very important, and it's the reason why it gives our molecules the shape that they have. Okay, so remember that electrons don't like each other. They're going to try to get as far away as they can from each other so they don't have to deal with each other, right? Because you have to think of it, well, if you were put into a room with someone you really don't like, well, are you going to try to sit next to them or stay away from them? You would try to stay away from them. Okay, so what gives the molecules the shape is because of the Vesper theory. Okay, so to use this chart, what you're really looking at is the central atom. Okay, you're looking at these two rows right here. So you're looking at the number of atoms bonded to your central atom, and then you're also looking at the number of lone pairs on your central atom. Okay, so we're going to be using this chart for these examples. So let me go ahead and pull up our examples. And then I'm going to have this chart right here so we can use it to refer to. Okay, so this is what we did in class today. We are going to take a look at the formula CCl4. Okay, so carbon chloride. Or since it's two non-metals, and that's actually carbon tetrachloride. Okay, so I was wrong. Okay, so to find out our molecular geometry, again, we do have to use our chart right here. Okay, so we're always looking at our central atom, right? So we're looking at carbon. So the first thing we have to look at is the number of atoms bonded to that central atom. Okay, so let me just make this bigger. Okay, so number of atoms bonded to the central atom. So if we're looking at the central atom, well, the central atom is carbon. And we have 1, 2, 3, 4 chlorines attached to carbon. So that means that the only possible shape that it could take would be tetrahedral. Okay, and then do we have any lone pairs on that central atom? No. Okay, the only thing we have are 4 bonds. So the shape for sure is going to be tetrahedral. Okay, so the shape that carbon tetrachloride would actually take would be this shape right here. Okay, so they're all going to be, so this is going to represent carbon, 1, 2, 3, 4 chlorines. Okay, I'm just going to draw the shape of it. Okay, so our next example, we have silicon dioxide. So how many atoms do we have attached to silicon? We have 1, 2 atoms. So it can either be linear or it can either be bent. Now, do we have any lone pairs on the silicon? And we don't. So that means it is not bent, it is linear. Okay, so we have a linear molecule, and it will look like this if we can see it in 3D. Okay, so that's what silicon dioxide would look like. Okay, so we have our next molecule. We have H2O. So let's count how many atoms we have attached to oxygen. We have 2. Okay, so again, it's either linear or bent. But then we have one lone pair here and another lone pair here attached to oxygen. So that means we have two lone pairs and we have two atoms attached to it. That means we have a bent molecule. Okay, so we have a bent geometrical shape, and so our central atom, oxygen, and then we have two hydrogens at the bottom. Now remember, with the Vesper theory, our electrons' repulsion towards each other is so great that it causes our elements to be pushed down. The other atoms are going to be pushed down because of the repulsion from the lone pairs. Okay, so next we have carbon disulfide. So we have two atoms attached to carbon, and carbon has no lone pairs. So if we have two atoms and no lone pairs, we have another linear molecule. Okay, so linear, and again, central atom, and then we have sulfur on either side. Okay, now we have, let me see if I can move this up. We have CH2O. So how many atoms do we have attached to carbon? We have 1, 2, 3 atoms attached to carbon. And does it have any lone pairs? No. So that means that it would actually take the shape of a trigonal planar geometry. Okay, so it's trigonal planar. So that would mean that our carbon is in the center, and then we have 1, 2, 3. Oxygen can go on top. We can have hydrogen here and another hydrogen there. It would take this shape right here. And if you want to get technical with it, well, technically we have 2 bonds here, and you can make these double bonds also. Okay, and the same with this one, if you want to get technical. Okay, and then lastly we have silicon tetrafluoride. So it's actually the exact same as our first example, carbon tetrachloride. Okay, so that would mean it would take the shape of a tetrahedral molecule. Okay, so we'll have our central atom in the middle, and then 1, 2, 3, 4 atoms spaced evenly. Okay, and that would give us a 3D shape for silicon tetrafluoride. Okay, so if you have any questions about the molecular geometry, remember the only thing you have to look at are these 2 criteria here. How many atoms do you have bonded to your central atom, and how many of lone pairs do you have on your central atom? That is all you have to look for to determine what your molecular geometry is. Okay, so again, if you guys have any questions, please ask. Okay, and I hope you guys have a wonderful evening.